modeling. So we have had these 4 different types of functions so far, right? We have worked with linear functions. We just finished quadratics. Earlier in the year we did exponential, and we also did absolute value for the beginning of the year. So you need to be able to distinguish between the models for linear, exponential, and quadratic. You need to be able to make a graph of each one. So I might give you a table and ask you to make a graph. I might give you an equation and ask you for linear, exponential, quadratic, or absolute value. I need to be able to write the equation, and the one that you probably will, and you'll notice on the board that we say tonight with question 15, you don't have to write the equation, because it's just not as easy to write it for some quadratics when the vertex is over and up, and so some of those will tell you don't have to get too worried about, but most of them you should be able to do, and then you can compare functions represented in a different way. So first form is our, if we are thinking about that, that was our point slope, right? So we had point slope form. That was our y equals. Remember we said m times x minus, when we wrote this earlier this year, we had x1 plus y1, right? But that really is the points that we are looking at, right? Kind of like our vertex point, right? So y equals, this was slope intercept, right, that we had. And this was our standard form. When we just finished with our quadratics, if we are looking at quadratics, that first form that you are taking a look at was our vertex form, right? This was our standard form. And there's one form we don't have up, which was our root form, right? And that's when you had a and then you had x minus your root with x minus root 2, right? So that was our, when we were looking at our factored form. Okay, so those are our different forms that we are looking at. And then this was our exponential. And so when we look at exponential again, we are looking at y equals, a is still going to be, if we are looking at that like our y-intercept, times b, that's our growth factor or decay factor plus the c point. So looking at these different ones again, the minus h plus k, minus h plus k, minus h plus k, kind of in all of those functions, so going back to our original linear form. So what you are going to be asked to do is to choose a graph. So it says students collected data on topics and they graphed it in these scatter plots. What type of function best matches the data? So looking from up above, you're just going to write in the word that you think matches. So I want you to either put linear, quadratic, absolute value, or exponential as you look at each one. So look at the first one, and it definitely will look, because it is a nice straight line, like what? Linear. First one is linear. Second one kind of curves, but probably not a parabola, so it looks like it should be exponential, and it is actually exponential growth. Okay. This third one, kind of symmetric, right? So definitely parabola, so we got quadratic. The next one down, those black dots up here, should be what? Exponential, and this time decay. And our last one, absolute value. Definite D. Okay? So as you are looking at those, that's one of the things you're going to be asked to do in your homework. I'll give you graph paper. You're going to be asked to graph the first few ones. Okay? So you will plot the points, and then you'll tell me linear, exponential, quadratic. Okay? As I mentioned right before we took our test on I, this is actually 2 units that were in chapter 9 that we didn't do. So now we are going to be looking at choosing the model for a table. So when you look at a table, you're going to be asked to get, I'm going to give you some tables today, and I'm going to say, okay, let's take a look. Looking at this table, do you think it is which one of those 4 types? So notice how my x is changing by 1, and the y has a constant change of 3. When the y's that have a common difference, remember when we did, going way back to our linear, This is when you are adding or subtracting the same thing. So when you have an addition, so a common difference might be adding, or you could be subtracting that same number every single time. And sometimes they might skip a number, like they might not have this -1, but they'll go from -2 to 0, then they'll go 0 to 1. This would still be a change in 6 divided by a change in 2. So if you have a change of 6, right, divided by a change of 2, that is still going to be adding 3 each time. It's just that they might have skipped sometimes a number in between. So here we go, -2, we can see that it's a constant addition of 1. But each time, and right away you might not see it, you kind of might think, oh, we're adding 0.25. But then you don't add 0.25 again. So as you were looking at that, you might look at some of them and go, okay, how do I get from 1 to 2, from a half to 1? And we are looking at multiplying. And anytime you multiply, so common ratio, is like multiplying by a number greater than 1, right? So if you multiply, or sometimes people like to think of it as division, but you might be multiplying by a number greater than 1, or you might be multiplying by a fraction, okay? So the key thing here is that you're always going to be multiplying. The number could be greater than 1, or you could be multiplying by a fraction. But you are always doing multiplication, okay? That's the key thing. That is exponential if you're multiplying. The next one's down. You start looking and you go, oh, they have a common difference in x. And you first start to go common difference because we know we're not multiplying, so we're getting from 1 to -1 and then to 1 again. But you do notice that these both gave you 1. And now if we get 2 is 7, I'm guessing if you put in -2, what do you think you'd get? If we don't know, but if we look at this table, we might think that it's kind of, so you're looking at it and you find the difference. So this is called the first difference. -2, then we added 2, then we added 6, then we added 10. If you don't see a common difference and you can't see a ratio that you're multiplying, check the second difference. The second difference means now I'm going to take the -2 to +2. That changes 4. +2 to +6 is 4. +6 to 10 is 4. That is called our second difference. It says for quadratic functions, the second difference will be constant. That means whatever the second difference is, if you continue to add the same thing, if you notice this pattern, it is going to be a quadratic model. So look for the first difference. If you don't notice a first difference, try multiplying. If multiplying doesn't work, try to look for the second difference. Okay? So in the tables that I provide you next, you are asked to determine the model. So what I want you to tell me is you are going to notice that our x's change by 1 in all of our tables, right? So what I want you to tell me is this a constant? Are we adding? Is it a constant addition? Or is it a constant ratio? Are we multiplying? Or do you have to find the second difference? Okay? So I want you to do that right now. Just telling me as you are looking at it. The first one you might start looking at right away, and what do you notice? Multiplying by 3, right? Which means it has to be exponential. Could we write the equation for that? Is it exponential growth or exponential decay? It's decay. So y equals, we started off with -3, right? It's decaying. So when we multiply by 3, if we start with -3, we're going to have 3 to the x power. And at 0, does that make sense? Do we have to add anything to it? Because if I put in x to the 0 here, right, I would have -3 times 3 to the 0. This is 1, and that gives me -3. So at 0, it's -3. If I plug in 1, I would get -9. So that would be an equation. So when you're asked to write the equations today in your homework, that's going to be another thing that we're going to be taking a look at. All right, next one. Anyone see what that one's going to be? Should be, sorry?
Linear.
It's going to be linear. So common difference was? -8. So minus 8. So it's linear. So I know it's going to be y equals negative 8x, right? That common difference. Plus, if I go, the opposite of subtracting 8 each time is to add 8, which would give me what for my 0 term? Negative 7, right? So I have y equals negative 8x. I can easily write linear equations. You guys should easily be able to write linear. Okay? Next one. Do we have a common difference? What did you find? So, does it look like multiplication? So first difference, what did you have down, Abby?
54, 66, 78.
Say it one more time.
54.
54.
And then 66.
Okay.
78. And then 90.
And what did you find for your second difference then?
12.
So, you agree, Kylie? So 12 each time, right? So this one is going to be quadratic. We're not going to write an equation for this one. We are not going to try and write equations for the quadratics from the table. We might try and write quadratics from a graph because they're nicer, but this one, we're not going there. You'll get to that later in your math career. Next one. Check with your shoulder partner, please. Angle is what? Linear. Everyone agree it's linear? Linear, adding what? Adding 8, right? How about the last one? Exponential. Okay? So, if we are looking at it, the linear one, if we are looking at linear, we said we are adding 8. So if we are adding 8, that is your rate of change, your slope. So y equals 8x. We need to find the 0, right? So at x is 0, what should we have? 8, right? We're adding on, this is, if we continue, this was negative 5, 4, negative 1. Where is 0? 0's next. Should be positive 8. Our exponential. What does it look like our ratio is? Times 3, times 3, times 3, times 3. Okay? So we know that it is 3 to the x power, kind of like we had here, right? But we got to figure out what's before that. So if I would put in 0, if I go back and I divide by 3, right? So negative 6 divided by 3 is going to give us negative 2. So I am starting at negative 2 times 3 to the x. Okay, does that make sense how you're finding that? So you've got to always find your 0 term for both linear and exponential in order to know what you are multiplying by. All right. So this next part says choose a model as you are looking at these. Label the following equation either linear, exponential, or quadratic. Okay? And we also should have, besides linear, exponential, and quadratic, we should also have absolute value. Now, absolute value, pretty easy. I can go through, right? I got absolute, right? I got absolute value. What's the key thing that distinguishes linear? Variable to what power? Variable to the first. So I got a linear, right? I got a linear, right? So I would like you to do the rest of them. I'm going to give you this one here. We are looking. No, we'll go to the next one. Should be, Cassandra, Kylie, what do you got? Exponential. Okay. Next one, Abby, what do you have? Exponential. This is vertex form of quadratic. Now, the exponent generally is going to be an x, not a 2. If it's a 2, that's telling you quadratic. If it's x to the first, that should be telling us linear. All right. Frickin' Dylan, what do you guys have?
For the exponential?
For this one?
Yeah.
I agree. Exponential. Linear, absolute value. Jake, you two back here, what do you have? This one right here. Y equals 13.5. Linear. It's a horizontal line, right? There's the variable y is to the first power. There's no x. It's horizontal. Y equals 13.5. That's a nice horizontal line. All right, we're going to the next one. Gavin, sorry, what do you have? Quadratic. X squared, right? You just put the y by itself, quadratic. Next one, Maria Ben. Quadratic. Taylor, Abby, what do you think?
Yes.
Linear.
Ooh.
And Josie and Liz, what do you think for the last one? Linear. Okay? X is to the first power. X is to the first power, right? Anytime you have x to the first power, you should be looking linear. Oh, but it also looks like point slope form, right? If we rewrite it with the y, it is point slope form. Oh my god. So all those forms coming back. So I would like you right now to plot these points, right? X is here, Y is income. This table shows a small theater company. Which type of function does it best model? Write an equation for your data. Okay? So, I also want you to see what your common difference is. So you might want to take out your calculator and calculate what is this common difference also. Because when you plot the points, right? You plot your points, and it's kind of hard to tell because the data is pretty close, so really we don't know if it starts curving or if it's a nice straight line, if it's linear or exponential. So you want to use both pieces of information when you do this. So, looking at the common difference in our table. What am I looking at for the change in y? Remember, this is change in y. First time it was what? 476. Next time it was what? 485. Next time it was 480. Next time
480.
is it both 480s? So we start looking and going, it's pretty constant, right? It's not exactly constant. Why isn't it exactly constant? This is a model. This is real life, right? This is how many, when they looked at the theater company, they're looking at their income. So should it be exactly linear when it's a model of a situation? No. So we think it's linear though, right? Don't you agree? If this is kind of constant, this looks pretty linear. It doesn't look like we are multiplying. So our change in y over our change in x, if we are looking, that's our slope, right? So it's about, what could we say?
480.
Now you could add those four numbers together, right? Those four changes, and divide by 4. Or you could look and go, oh, I have 2 480, 1 485, 1 476. It's about 480 for my rate of change. Does that make sense to everyone? My dollars is $480 per 1 year, right? That's what it means, okay? $480 for 1 year. So now we want to write our equation. Do we know our y-intercept?
Yes.
We know our y-intercept is our 0 point. So we can write our equation, write an equation to model it. Y equals 480x plus 18,254. Okay? So as you are doing the problems, this is kind of what you are going to be looking at. Okay? So your homework assignment is 592. It's 6 to 20 all. And notice we ask you not 2 for 15 to write the equation. And the main reason is probably that. And it's not as easy to come up with. Okay? So,